Wait a minute. So you're probably wondering what I'm doing here, and the reason I'm here is because on October 10th, I was driving this car in Modesto when this idiot ran a stoplight, and we T-boned him.
No Boykins were harmed in the making of this film.
Today we're going to talk about how the impulse momentum theorem informs car design that saved my neck. Okay? All right, sweet. So, what is impulse? What is impulse? Impulse changes momentum. Momentum is just how much mass you've got going at how much velocity, and in order to change momentum, you need an impulse. An impulse is symbolized by the capital letter J. Whoops. Oh. And so here's the statement: the impulse changes momentum. This is called the impulse momentum theorem. And what is impulse? It's force exerted over a time interval. And when momentum changes, what changes? It's the velocity that changes. All right, so I want to demonstrate
The koosh.
how this works. I've got a I have a koosh ball, but I can't find it, so I went out and found this cute, cuddly thing.
Let's
And it has the same mass as this golf ball. It has the same mass, so if they're going the same velocity, they have the same momentum. And as the velocity changes is the same, the change in momentum is the same, the impulse is going to be the same to change the momentum. So let me give a little demonstration here with the koosh ball. Okay. And then I'll do the same thing.
Little guy.
I'll do the same thing with the golf ball.
Oh! Boykin, are you okay?
Well, yeah, slightly bruised, but the impulse was the same for both. The change in momentum was the same for both the koosh animal, I guess is a hedgehog, and the golf ball. Why is that? Well, the golf ball hit me with more force, which hurt. The koosh ball hit me with less force. They both had the same impulse, so how come one hurt and the other one didn't? It's the amount of time that it comes in.
Oh.
As this comes in, it first makes contact and it starts to
Koosh.
squeeze and koosh, and then it comes off. It takes a long time for that to happen. The golf ball comes in and clicks, no koosh. So what you have is the change in momentum. The impulse is the same both times. And with the koosh ball, you have a small force and a large time interval. And with the golf ball, you have a large force and a small time interval. And they both equal the same. You can have 2 times 10 is 20, and 10 times 2 is 20. And don't bounce a golf ball off your head. It hurts.
So the golf ball was more force and hurt more because it was on there for less time.
Exactly.
Okay, that makes sense.
Exactly.
Woohoo!
Okay, has no koosh.
Not enough koosh.
All right, speaking of no koosh, this is called a ladder frame, and it's the earliest type of frame for automobiles that over 120 years have been made with ladder frames. Let's take a look at a ladder.
Look at that plant. Okay. Being the recorder is fun.
I know. So here's a ladder, and if you're...
Wait, where should I go?
I don't care. I don't care. Just
my job got harder.
So the thing about a ladder, as you climb it, you don't want it crumpling this way. It needs to be rigid along its length, okay? And so you've got these 2 rigid rails that are connected by rungs. And that's why this is called a ladder frame. You've got 2 rails that are connected by rungs. It's the simplest, cheapest way to build a car or a truck. You can put the engine on the front, you mount the suspension, here's the transmission, the drivetrain with the rear end in the and then you just plunk a body on it, whatever kind. This is an SUV.
This is why Boykin is explaining this.
You can have trucks, whatever. In fact, and it's a very inexpensive way to make a vehicle. The problem is they're longitudinally rigid. They don't have as much couche. It's more like a golf ball because they're rigid and they don't crumple. Whoops. This is called a unibody frame. And basically it's separated into 3 parts. You have the front, in this particular, here's the engine up here. This is designed to crumple in a crash.
Jakoosh.
And the back. This is designed to crumple in a crash, and the passenger capsule is designed to remain rigid. Just like this. Here's the front end that's crumpled in my car, and yet the doors open and close just fine. Just fine. Notice what the hood's doing here.
Oh, it's kind of that. It's bent up in a little like.
Yep. Okay, so here's a diagram with the passenger capsule that's designed to be rigid. You don't want anything coming in on you when you're driving down the road, when you're in a crash. The front is designed to crumple. That increases the amount of time. It decreases the force on the passenger. Same thing if you're hit from behind. It's designed to crumple up. And even though I was very angry about this meathead, he was probably on his cell phone when he ran through the light, ruining my car, it's worth the sacrifice for me and Mrs. Boykin to still be okay. Here is a video. Let's see, how can we get this? What, I just drag it over there?
Mm-hmm.
Well, why don't you come over here?
It was like Boykin in his element. All right, here we go, you guys.
Here's a crash. Notice the crumple, the airbags go off, and the people go in. Let's see that gory thing again. Come on, come on, come on.
I know, the mouse is.
All right, the front end stops, the rear is still going forward. The airbag inflates before the dummy goes forward into it. And what it does is it prevents you from going. It looks like it's nice and soft. I want you to know that it is not nice and soft.
Nice and cushy, right?
Yeah, it is not nice and soft. You'll notice here, the windshield is cracked. The airbag did it. The airbag is like an explosion.
Oh.
So what you want is you want the car to crumple up. Even though that car is no good, the driver's still in good shape. But what do you notice about this car? They didn't have, this car is an older car that did, you have autoplay on.
I totally do.
Messages forge better connections. And emails that get the job
What
done.
is this?
You need to think about more than just
You guys, if
grammar
you're
and spelling.
if you're struggling with with writing, Grammarly could be your answer.
I turned
Oh,
autoplay off.
thank
for
you. That's how you do it. Okay, come on.
Yeah, right. Let's see, where are we here? We need to go. Boom. Boom. Okay?
There it is.
And notice how this is crumpled up. The hood is crumpled up. In the old days, in a crash like this, the hood would go back into the passenger compartment.
God.
Bad things would happen.
Guillotine.
So cars nowadays are designed, here's the underside of a hood, and notice the dimples here? They go all the way across the frame inside the truck so that in an accident, when it's hit in the front, it bends like this and doesn't go back into the passenger compartment.
And slice them in half.
That's a good thing.
And it's a good thing.
All right, let's go back to the impulse momentum theorem. Here's Newton's second law, and we've already asked this question, how these are alike. Well, what is acceleration? It's the rate of change of velocity. It's delta V over delta T. So if I divide this by delta t, I have exactly the same thing. The impulse momentum theorem is just another example of Newton's second law at work. Okay? And it's a law. You know, you can't beat the laws of physics. Okay, momentum and impulse are both vector quantities. They have magnitude and direction. If the impulse and the momentum are in the same direction, momentum increases. If they're in the opposite direction, momentum decreases. Allow me to demonstrate. I got your cart. Look, it's going that way. I give an impulse in the same direction, the momentum increased. Okay, now the cart is going in that direction, the impulse is in the other direction, and the momentum decreased. Okay, it's a simple thing. So because they're vectors, they have direction, positive and negative, north, south, east, and west, up and down. Okay, on a force versus time graph, the area, here's a force versus time graph. The area between the line and the x-axis is the impulse. For example, with the golf ball, force, time, you have this much area, a very small amount of time, and a very large amount of force when the golf ball is attached to the head. With a koosh ball, force, time,
So it's the same area underneath there.
this area is the same as this, because I said so. But notice the force is not, it doesn't hurt. Would something this cute want to hurt you?
I love it.
No. So the area under the line is the impulse. Why is that? Well, it's force times time.
Ooh.
Force times time. Now this says solve for each variable. You're probably insulted by me asking you this. How would you solve this for force? Divide both sides of the change in time. How would you solve it for mass? Divide by the thing you don't want. It's a simple thing. Now, let's figure out some way to use this stuff. Okay, so notice I look much better with this on. See you guys. Nice talking to you.